Hello, this is the last nail about our examples of so-called runtime macro system of Clojure custom bare bones runtime macro system. And today we'll finalize our desired order allowed function, but using with only a runtime approach without letter and without macroses. So in previous nail we explained how we implemented and overcame some corner cases about a so-called lambda let, a lambda which allows us to construct a forms to explicitly evaluate them and emulates the let special form behavior. And today we will implement our famous cond_let macro, but implement it as a regular function, not as a macro. It's some little tweaks and it's very close, looks very close to the actual cond_let macro. But then our previous explained order allowed function, now we will use cond_let, but not as a macro but as a function. We will wrap all the cases in a vector and we will quotate this vector so to avoid this evaluation before it needed. And then we actually have to call extra eval function here. But let me first show you which forms will be passed as argument for eval function. Order allowed, let's evaluate the first form. And here you can see in REPL no let as a special forms, nested inline lambdas, and nested if blocks. If blocked, then blah blah blah, so call function of flag, call function delta lag, and so on and so forth. So our common and usable approach. But as was explained in previous nail, if we will call eval directly here, it will return an error, unable to resolve symbol blocked in this context. What does it mean? Yes, as we explained in previous nail, these symbols are not allowed for the eval form, even if we use it here in the body of eval form. So how we can overcome it? Like we did in previous nail, we can add here an extra lambda let block. Actually, I already prepared it here. And then only copy paste is needed. And here in this extra wrapped lambda let, we actually duplicate all the passed income parameters and bind it inside the eval form. ID is ID, name is name, block is block, and order amount is order amount. And for now, let's first comment the eval form. Let's see how it will return the form for eval itself. Slightly more nested lambdas. So now you see the big form for evaluation. And these lambdas has their own formal parameters: ID, name, blocked, and order amount. And then all internal form, it depends only of these names of parameters. But actual values of these parameters are 1, Andrew, true, and 10. That's actually 1, Andrew, true, and 10 for form parameters of formal call. And again, if we return eval, external eval wrapper back, reevaluate the function, and then do the calls, everything's fine. For blocked customer, it returns sorry Andrew, you are blocked. For a big amount of order, sorry Andrew, your balance exceeded by blah blah blah. And for sufficient amount of order, okay Andrew, you might have an order, the rest of flag is 5 and balance, the rest of balance is 30. And I want to put your attention on that fact that the actual call of this function is exactly the same as if we had before when we used cond_let as a macro, when we had let as a special form. So all the tips and tricks, all the extra noise is hiding inside of function order allowed. all these quotas, all this lambda let, all these eval wrappers, and so on and so forth. So the actual public API is exactly the same. So it's a huge thing from my point of view, that we can hide all that annoying and noisy things inside of functions, and then call them as a regular one. So that allows us to forget that we do not use Clojure macro system and use it emulation via lambdas. And the final case I want to show you here is that actually while we have cond_let here, we may not use a regular way of using lambda let on the top of forms, but we can use their construction of internal let, so-called internal let. That's the same way as lambda above, but here we pass all the actual values of the input function parameters inside the cond_let function, and then a cond_let function construct the let binding forms, which we implement as inline lambdas. Yeah, so let's see how it works. Okay, yeah, and it works the same way. So we have at least two ways how to overcome the situation for eval, for making the exact evaluable form for the eval here. Maybe that's up for this block of so-called inline macroses and inline macro system. Maybe later I can show you some extra things if I found out some even more interesting. But it's enough for this group of nails. I hope we clarify a little bit how we can emulate macroses in runtime. So see you next nails.